to conferences all the time is the main driver for progress in your skill set and also your relationship. And basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi everyone, welcome to my talk, Testing and Releasing Elasticsearch and the Elastic Stack. And yeah, that's kind of sums up our topic for today. So I want to talk about testing, like what we do within Elasticsearch, what we do within the Elastic Stack, and of course, I also want to talk about releasing, because I think it's part of the whole process, otherwise software is not ready. So what will you learn today? We will go from this, which is basically just a list of commits in a GitHub repository, to this, which is a ready-made product that can be downloaded. And it's a huge difference if you're basically running something as a service and you are able to update the platform continuously in the background, or if you're basically need to provide a product with stable releases, like this has to happen with the Elastic Stack. And it's not just Elasticsearch, right? There's a ton of products around the stack which are also released at the same time. So we have to make sure that everything is ready the moment we want to release a new version. And on top of that, we also run a part of our products as a service ourselves. So you can basically spin up a hosted Elasticsearch Kibana and parts of the stack in Elastic Cloud and run it in there. So the moment we release software, we also have to make sure it runs on Elastic Cloud. So today's goal is basically transfer a little bit of the Elasticsearch testing and automation knowledge that we have into your own project. That said, hi there, I'm Alex. I work for Elastic. I joined about 7.5 years ago. I was part of the Elasticsearch team for a couple of years, and now I'm a community advocate. And yeah, I'm also a huge distributed working fan since 7.5 years basically. So if you have any questions about that, you can catch me later. And just to set the scene and where we're at, you may have seen this picture, or may have known products that are part of this picture, like Elasticsearch, and all of this together is basically the Elastic Stack. So you can consider it a set of building blocks, if you want, to implement different solutions like observability, log centralization, observability, APM, or security mechanisms, using it as a security incident event management system. Or things like workplace search or app search. And there are different building blocks within there, like machine learning and so forth. And I've been using Elasticsearch when I started with it kind of 10 years ago as a B2B product search engine. So this was the kind of classic full text search use case. And nowadays you can basically just pick the kind of blocks you want and you want to use. But most of the time today, I'm not talking about Beats, Logstash, or Kibana. This will be about Elasticsearch, which is a Java-based software, and how we test this. So Elasticsearch itself is a full-text search engine. Think of it as Google or Wikipedia. Everything you type into Wikipedia is basically an Elasticsearch query. But there are more than those use cases. You can also use it for more than business intelligence use cases if you want, or analytics. You can use it for geo-based search if you hail an Uber or you search for a restaurant with Yelp. All of this runs against Elasticsearch. It's distributed and scalable, so you can scale up or scale out, like buy faster hardware or buy more commodity nodes and basically create a cluster. It's highly available and resilient, and highly available refers to the cluster, so that all of your data is available even if a single node fails. And resilient in this context means that the cluster itself detects if a node has an outage and removes it from the cluster, for example. The interface is HTTP and JSON. The idea behind this is that it's the kind of platform that most people know and are familiar with, being as a protocol and an object notation. And as I already mentioned, it's the heart of the stack. So what do I want to cover today? The first thing we're going to take a look at is unit testing within Elasticsearch. Consider this the kind of lowest kind of testing, the fastest feedback loop if you have. And then we take a look at integration testing, where basically instances of Elasticsearch need to be spinned up. We're going to take a look at the packages and why it's important to test those. We're going to take a look at backwards compatibility testing, which I think is crucial if you want to make sure that your users are actually upgrading and they're not stuck on the version from 2015. We want to also go through documentation testing, because I think if you have invalid documentation on your product out there, it's really hard for the users to get up and running with it. And of course, we have to cover something like CI, like how's the test matrix looking like, what kind of tests are we running, and of course releasing, again, as I said at the beginning, unreleased code that is just committed to a repo doesn't exist for anyone else but for the author. So let's take a look at unit testing. I would just assume some basic Java knowledge here. So this is a regular test class if you want. There are test methods in there. Every method starting with test is basically considered the test method. It will be run. And the interesting part here is the ES test case. That is basically the base class for testing. And if you open that one, you see a bunch of annotations. If you're a Java developer, you're probably used to seeing a bunch of annotations. For us, the most interesting part here is the Lucene test case class. And if we dig deeper into that, we see more annotations, but the interesting part is up there. That's a so-called run with annotation. This basically configures a so-called runner for JUnit. So this is the kind of class that decides how the tests are run. And if you check out the Java documentation for this, there's an interesting definition. And it says, an implementation for running randomized test cases with predictable and repeatable randomness. So you try to be random, but it must be predictable and repeatable. That sounds kind of weird. So let's take a look what this actually means. So the idea behind this is that the test class is equipping you with a couple of methods allowing you to create random data. So random string would, with every invocation normally, return a different string, a different alphanumeric string of length 10. Random boolean, one of those two random booleans. Then you can have a random list of integers, a random integer from a range. Non-negative long, you can also implement your own methods. Like for Elasticsearch, we need a lot of time zones because we don't want to depend on the system time zone, or a random locale. So all of this can basically be done. And what is the advantage of this? Of course, this is a kind of useless test. You want to get back a random string with a length of 10. You want to make sure that the string length is 10. This test would of course fail because the string would always have the same length. But let's take a look at a more concrete example. Imagine you would like to add two integers. We want to make sure that those integers are positive. So in this example, there's an assert, a greater than 0, b greater than 0, which basically means that this would only work if you start the JVM with a certain parameter to enable assertions. But let's assume that for now, and we could write a corresponding test. And the test could look like this. Like we call add on 1 and 1 and add on 2 and 2, and we assume that the result is 2 and 4. That's a test. It will never fail, but have we really covered all test cases? And of course, you wouldn't want to write all the test cases in there. But what you could do instead with randomized testing is you just want to get a random integer in the range of possible integers for value a, same for b. And what you expect is basically that the sum of those should be greater than the initial value. So if you do a plus b, the result should be greater or equal than a and greater or equal than b. So you run this test, it passes, is everything fine? Well, you're not so sure. What can you do? You could run it a couple of times. And randomized testing allows you to just add a so-called repeat annotation and run this test 1,000 times. And suddenly you figure out that this test will fail around about 50% of its runs. What happened? Well, this is the assertion error. And the assertion error claims that there is a number which is smaller than the initial input. Which kind of makes sense because the integer at the top can just overflow. So you end up with a negative number if the total sum of integer a plus integer b is bigger than integer max value. The good thing here is that we now have the ability to reproduce this. So we still retrieve random integers, but by specifying a concrete seed, which is mentioned in the test failure, you can basically run the same test with the same numbers all the time. So this way you can actually dig into the problem, fix the problem, remove the seed annotation again, and have your randomized runs. So just by running a test often enough, which for sure helps on developers' notebooks or on CI, you will cover a lot of ranges of numbers that are about to be added without having to write a concrete use case for every test. And this is the power of randomized testing in there. The ES test case class has a couple of more goodies in there. So there's a thread leak detection. If you're basically starting a thread in your code and you're not properly closing them, then the test will fail. You can change log levels for single tests or packages. You can also check if something is written to system out or system error. Most of the time your application should not write anything to that, because you never know in a server-based or daemon-based application if the file handle gets read. The test method order is randomized, so this should ensure that basically no test is dependent on a test that has been run before. All of your tests should be able to run independently. The same applies to all your test classes. And there's a couple of extra Elasticsearch specific checks, like for a feature called deprecation logging or so-called search contacts. Also, the test runs get parallelized. So by default, the tests are split among a random number of among a number of JVMs, so they can run in parallel. And this number of JVMs is based on the CPU count in your system. Let's move on to integration testing. So HTTP is the main interface of communication, which also means that HTTP should be the interface that Elasticsearch tests against. And in order to do this, there's a dedicated test suite that is written in YAML, which is based on the JSON API definition. And we can run this in Java by extending a certain test class, but also all the official clients. So basically the Perl, PHP, Python, Ruby, Go, .NET, and the Java client. They are basically also using this spec, and this makes sure that even all the clients are basically having all the features that Elasticsearch as a service offers within its APIs. So this is a really, really important test suite for us as Elasticsearch developers. This is what the API definition looks like. It's basically defining like what path exists, which HTTP methods can be used, what certain fields should look like. Should it be a string, a number, and so forth? Do you have additional parameters? So it basically allows you to define how an endpoint looks like. And this is what the YAML test looks like. So in this example, we are basically indexing a document into the index test1. This is the index action, the first one with the do prefix. And then we retrieve back this document. And retrieving this document means that we just use the match assertions at the bottom to see if the JSON response actually matches what we expect it to be. If there's an exception, for example, because the document is not found, the test would fail. And only if those matches at the bottom are actually passed, then the test will also pass. So what else do you need to do in integration testing? Well, if you have third-party integrations, you need to test those as well. Elasticsearch has a pretty extensive security extension. So we want to make sure that it runs with Kerberos, with Samba, against OpenLDAP for authorization or authentication, using Shibboleth, a SAML identity provider. All of this can be done using Docker and Docker Compose. Same applies to integration testing against other storage mechanisms like S3. And of course, as part of the build, Elasticsearch creates its own Docker image, and that one can also be tested using Docker Compose. Next up is package testing. So Elasticsearch comes with a lot of flavors. Like you have 4 different files to download, like the targz, the zip file. You can download the Debian package, the RPM package. You can download apt and yum repositories, so you can just run apt-get install Elasticsearch. There are Docker images, there's an OS X brew tab, there's a Windows MSI, there's a Helm chart, there's also the ACK, the Kubernetes operator, Elasticsearch for Kubernetes. There is Puppet, Ansible, and Chef integration. So basically it means that there are lots of different formats where you want to make sure that everything works as expected. And we want to make sure that the artifacts that are produced during a build are tested already before we copy them somewhere into an apt or a YAML repository. So what basically happens for Elasticsearch in order to test packages is we need to run these on the distributions that are officially supported. You can use Vagrant to basically download all of these. And in this example, you can see that there's a fair share of distributions that are supported. Especially the LTS releases from those distributions need to be supported. And there's also Windows being downloaded. So there's just a lot of different testing systems or systems requiring tested. And you can also see that there are different distributions where we have to make sure that the one Debian package we have, it also works on Ubuntu, it also works on Debian, the RPM package that we have. It works on CentOS, on Oracle Enterprise Linux, on OpenSUSE, on Red Hat Enterprise Linux, and SUSE Linux Enterprise. So there's just something there we have to be sure that our packages are supporting all of those. And the way we do this is basically spin up a virtual machine using Vagrant, install the package, upgrade it, delete it. We use something called BATS, Bash Automated Testing, which allows you to write something like unit tests within your shell. And we could check the return codes from the installation and see if the service is up and running. That unfortunately is a little bit stuck on the development side, so everything here has been moved to Java. And so within Java, we basically run the package installation calling dpkg-i to install the Debian package, or rpm-i. We try to start the service using systemctl nowadays. Back then, we also had to use sysvinit, depending on the distribution. We see if the service is up and running. We stop the service, we uninstall it. We can also emulate upgrades from an older package. So there are many, many things that you can actually test when you want to test those packages. Yeah, if you want to take a look, you can basically take a look at the bottom where the dedicated QA directory for just those package test modes. This is really important, like the backwards compatibility testing. Like if you're not backwards compatible with your product, it's going to be really, really hard to make sure that your users are actually upgrading, right? Like if you're stuck and you don't give them a proper and clean upgrade path, users are always going to be unhappy and will either stick with the old version, but they don't want to throw away all the data and then start the whole index operation again. So when you offer something like backwards compatibility, you have to test this kind of compatibility guarantees, right? So what does this mean for Elasticsearch? For Elasticsearch, this basically means that upgrades must be supported and tested. So if we say that you can upgrade from this version to that version, and you can do a rolling upgrade or you can do a full cluster restart, we really have to guarantee this, right? So it also must be part of our tests. So whenever we run our tests in CI, we have a couple of tests that take the current build, the zip file or the TIGZ file, unzip it, start a second machine with the same setup, and then start an older machine and sort of do a rolling upgrade. We also have tests where we basically do a full cluster restart. So we start a cluster of old machines from older releases or from previous releases, index some test data, run some tests, then we shut it down and start everything up with a new system with the current build and see if this one is working as well and rerun those tests. The same also applies for rolling restarts. So if you do rolling restarts between minor versions, we also want to make sure that everything works as expected. And in our case, this means that you would like to support rolling restarts from the latest major version to the current major version. So what happens here is that you have an older cluster with the current 6.8 version, 6.8.12 that will be. And if you have a 3-node cluster, how do you do a rolling upgrade? Well, you bring up one node, you bring down one node, you upgrade it, you start it up again. When it starts up, it's going to join the cluster and keeps humming. And you would essentially be doing the same for the second node, and you would essentially be doing the same for the third node. And this kind of action can basically be done automated within your system or within your tests. So you can basically we have a Gradle test that allows us to do just that by starting up 3 instances, bringing down the first one, replacing it with the current one, and do it for the other 2 as well. So this kind of upgrade scenario is so important for us there we really want to make sure that this is properly tested. All right, let's talk about documentation testing, because everyone is doing this, right? This sounds at first like it's not needed or it's a lot of work, but I think it's absolutely crucial, because if people start copy-pasting from your documentation and things don't work as expected, things return error, the responses are not what is expected, this leaves a really bad taste in the mouth of the user. So for Elasticsearch and all the Elastic Stack products, all the documentation is written in AsciiDoc with a couple of extensions so that you can link between the different products. Also, the documentation is always part of the repository of the product, so you don't have a separated repository. This also implies that whenever you add a new feature or you change an existing feature, you as a developer are forced to update the documentation as well. The idea of documentation testing here is that you fire up a test cluster that can even be a single node cluster in the Elasticsearch case. You extract all the snippets from the AsciiDoc documentation, just collect a big bunch of them, and then run those snippets against the cluster and check if the response is what we expect it to be. And optionally, you can also check the response contents. So a sample snippet would be something like this. Get Twitter doc 0 means that you're trying to retrieve a certain document. If it's marked as console, like in the first line, this is supposed to be a test that will be run. And it also means that we have to do some setup work, like in this case, create a Twitter index and index a Twitter document before this call is supposed to be successful. This is basically what it looks like in our documentation. This is rendered as a special snippet. You can also open this in the console on your local installation, or copy this as a call request. And on top of that, you can also check the responses. So in this example, that will mean that this is the response of this get call that you saw previous. It's marked as console result at the top. And we can also do some sort of assertion. So you can see at the bottom that we are replacing the dynamic parts that are potentially changing between two executions, like the sequence number and the primary term field. And so we basically make sure that we can compare the response that we have in our documentation with the response that has actually been returned from the request. So we know that the underscore source feed, for example, which contains the original JSON, will contain the right values. All right, next up. Do not have a million build systems, or do make sure you reduce the number of steps to create a release. I think this is what this is about. So for Elasticsearch, Elasticsearch has a massive Gradle build nowadays because it just uses Gradle for everything. You don't need any second build tool. It falls back friendly, so if you don't have Docker or Docker Compose installed or Vagrant, it tries to run the other tests as well, so it doesn't fail hard. And this is really important because we want to make sure that everyone can run the tests without having to have a huge setup locally. The only requirement is a recent Java version, and that's about it. And the rest gets downloaded automatically, just like Gradle as well. Every test run can be triggered via Gradle. That also is crucial for Elasticsearch. That also makes it easy to reproduce. We can just copy paste the failures from CI and go from there. And of course, you can always try to reduce the dependency on external tools. It won't work in total. Like, you don't want to rebuild something like Vagrant, Docker Compose, things like that if you run integration tests. But you can still try to reduce the overall dependencies of those tools. So maybe at some point in time, like we did with Bats, if there's an external dependency that doesn't get developed any longer, it probably makes sense to try to ditch it and replace it internally if you don't want to have the burden of additional maintenance. Let's talk about testing of contribution. Of contributions. So Elasticsearch is an open source project. Parts of it are open source, part of it are under an open license. It depends which code you look at. But this means there's an open public repository where users can create pull requests. Same applies for all the developers. So the build of Elasticsearch itself takes a lot of time. If I run this on my notebook, I think it takes at least 2 or 3 hours nowadays. So what you really want to do is either have everyone really beefy machines for testing, or you want to run every pull request automatically. And every commit to an open pull request from a member of Elastic basically triggers a new CI build so that you get quicker feedback if this commit fixes the test issue. The test can be triggered via GitHub as well, so you can do this. You can also, we have a bot in the background that allows us to merge against the current branch the pull request is built against, and again run the test via GitHub, so that you basically save some manual work and push to your branches. And yeah, this is basically how it looked like. You can see here that there's a lot of Elasticsearch builds at the bottom, CI1, CI2, BWC, default distro. The reason for this is that we try to run as much as we can in parallel so that the total time of your pull request gets as small as possible and you get quicker feedback instead of running everything serialized. And you can trigger this manually as well. You can just run Elasticsearch CI1 and CI2. So if there's a certain test that fails and you know this is not your fault because it's a kind of a random test failure, you can just rerun the test and see if it passes, or you just fix your code to do another push and everything gets built automatically. Also, if the CI fails, basically there's a ping to other people in the Elasticsearch channel, especially to the last committer, that the last committer should take a look, because maybe that user has actually introduced a bug that probably has not happened in the pull request itself, like a randomized testing bug. Okay, let's take a look at continuous integration. So Elasticsearch has a lot of CI jobs, if you want. Like, based on all the branches, there's, for example, documentations for every single branch where the tests are running. For the latest branches where still releases are being created, there's a fair share of tests. And if you scroll down here, you see that is a lot of jobs. Right at the bottom, you see the jobs running the pull requests. So all of this is within our CI infrastructure. You can see what the CI build system is here, is Jenkins. There's a fair share of CI slaves, so quite a bit of things that are running. You can see at the top that there's the different projects running, like some branches, Elasticsearch 6.8, 7.4, 7.5, which by now are not built anymore because it's not a supported version anymore. There's the master branch, but even within this, just a single job doesn't mean that there's only a single execution of something, right? For example, we want to make sure that Elasticsearch runs on many different JVMs. There's a certain set of JVMs that we want to support. And so we have to add this to our CI as well. You can see here we run on Java 11, 12, 13, and 14, different distributions like the one from AWS, like Adopt OpenJDK, like Zulu. So we want to make sure that we really run on all those different JVMs without problems. And the same also applies to packaging of Unix systems. So here we want to make sure that on all those different operating systems, as shown at the beginning, the packaging tests are successful. So this is running as well with a lot of tests. And you can see here it's a so-called multi-job under Jenkins, which basically is just a fancy way of saying there are a couple of sub-jobs which need to be executed as well for this whole test to pass. So what are we building? Just a quick reminder, and this means you will have a certain infrastructure, but every single bug you catch before the release is really important to us because of the huge adoption of the stack. The more bugs we catch before release, the better it is. So we basically test all active branches. We test every pull request commit that gets tested to ensure that there's the shortest possible feedback for the developer. And that accumulates to several thousand builds a day easily, depending if you have a busy day or not. So this is just a lot of traffic and a lot of CPU cycles, right? So our CI infrastructure is rather big, and this is just for Elasticsearch. Every product has basically their own CI infrastructure that they use for these kind of things. So how do you make sure that you keep the performance of your product? And I think this is also part of testing. This doesn't need to be testing of what the developers are working on a day-to-day basis, but I think it just makes a ton of sense to have some sort of nightly benchmarks. And this is exactly what Elasticsearch is having. There's a bare metal system which is running every night a certain set of benchmarks. You can see here there are different kinds of benchmarks. Some of them are very query-based, some of them are index-based. Some of them have special data like HTTP log files or GeoPoints, so it's kind of very different data sets for Elasticsearch, but because it supports these features, you want to monitor all of those. And this is kind of the output. Every dot is, or every point on the right graphic is a nightly run, and that allows you to easily spot performance issues, right? You can see here that there was an upgrade to a Lucene snapshot, and the Lucene snapshot apparently introduced a performance issue or a memory issue on the right, that the same data set suddenly needed a lot more memory, like 40%. And you can also see like a few days later, like a week later, week and a half, this was actually fixed and everything was back to normal. And just by looking at the graph, this allows you really to take a close look and figure out what is broken. Yeah, those are the number of builds per day. So this is from our CI stats. And you can see here that there's fewer builds on the weekend. This is because many folks are basically working on Elasticsearch during the daytime as a paid job. So you have a certain reduction of all the pull requests, but we also have a fair share of builds that are triggered automatically in the background just to make sure that we catch certain failures. If you want to know more, you can take a look at the different CI implementations here. I'm happy to drop those links in the presentation later on as well. But let's talk about releasing stuff, right? Because everything up until now is still not at the customer. So for us, every product in the stack will test differently, right? Like we have a zoo of programming languages across all of the different products, and it doesn't make sense to try and unify this. That would just be a lot of work, and all of the developers of their respective programming language would probably be unhappy because they have to adhere to some sort of testing standard that is not part of their language infrastructure. Same applies for all of the different configuration languages. Like everything we have needs to be taken care of as well. So you probably have to embrace the difference because there's no way you're going to unify that anyway. So how do we do a release? I said at the beginning that we do releases for a lot of our products at once, and we always add more of those products to our releases. So first and foremost, releases are time-based. Every couple of weeks, there's a minor release or there's a patch release, and every couple of months, there's basically a minor release with new features. So those are considered time-based, which means at some point in time, every product branch should be ready to release. So every release, like a 7.10, every product has a 7.10 branch. And the next step is to build all the release candidate artifacts. So there's one big build, which I think is still in Gradle, where we create basically release artifacts of all the products at once. Then those artifacts get tested. And if there are blockers found, if there are issues found, this step is basically repeated until every product says, like, I've fixed all my crucial blockers. From now on, this is ready to release. And an important point here is the moment we do a release, we do not recreate those artifacts. We take those artifacts where everyone has tested with and basically put them online. And this to me is an important step. This way we can really guarantee that those artifacts are what they claim to be. There's the position of a release manager. So there's a person responsible for the release. And this person basically triggers the build of all the artifacts, triggers a new build if a blocker has been fixed, and also makes sure that if there are any follow-up tasks for each team, they need to be done after the release. So that's the one part. And of course, as already mentioned, the staged artifacts are the final release artifacts. We don't do rebuilds. And there needs to be a process that pushes these artifacts to their final destinations. And that's quite some work if you think about it, right? You need to push to Sonatype for your Java dependencies, but it needs to be in the staging part, so it's not yet public until the moment we push the release button. Same for Ruby gems. You need to push Docker images. You need to update your package repositories. You need to update official links. So like you can't just push artifacts into the destinations. You're basically kicking off a whole engine that starts to work. For Elasticstack, those are like 200 artifacts that have to be promoted somewhere. And the release process has been changed over the last couple of years to nowadays use TestCon pipelines within Kubernetes. So you don't have a single process anymore doing all of this artifact promotion, because that was really slow and tedious. Nowadays, you basically parallelize this using pipelines, and now promoting artifacts was like 4 times faster than before. And the third-party promotion to things like Solartype, Ruby gems, and so forth is now a lot faster. And this basically has reduced the release process. And I think it's about 40 pods nowadays that are responsible for a single release. And even after that, you have more work, right? You have to update website, communication, release blog posts, ensuring everything has been published to make sure you haven't forget anything. But there's one more time, which is not fully part of the testing circle, you might think at the beginning, but I think it is. Because if you have older versions, you still need to support those older versions, right? Which also means you still have to test it. If there's a bug in that older version, can you always just say upgrade to the latest one and be sure it works? Or do you have some sort of special long-term release older version? So these kind of things are important, because if you don't have any rule or policy for phasing out your products, they will be used into eternity. So at some point you have to decide you stop supporting old products, you're not writing bug fixes, you're not doing testing, you're not adding features for sure, and you have to do this in a consistent manner. So you have to guarantee support for certain products, and also what the upgrade path looks like. So you have to provide the maintenance policy, you have to decide at some point, like, what does end of life mean? Does end of life mean that like you're not even doing any bugs, no matter if they end up or mean a data corruption? Or does end of life mean like only really crucial bugs? So this is something you have to define, and at some point communicate to your customers, right? You have to say like, this is our end of life policy. Those are the products, those are the dates until we support this, and at some point we're gonna stop supporting things. All right, coming up to my summary slowly. So if you have any questions, feel free to put them into Slido and I try to answer those. And one of the things I want to talk about is basically that you should automate early and you should automate often. I think that's really crucial. And so, for example, we started rather late to decide that we need a unified release process, which basically grabs all of the products, builds them, creates the artifact. So before that, there was always a really manual step, and that was a lot of work because we did this rather late. And I think the earlier you automate this kind of things, also the less afraid release managers are to actually do this task, right? It should not be a big thing to create a build of the products you write every day and put them somewhere to test. But if it is, people will shy away from releases, and suddenly you end up with this major releases that are not fully tested because it's not been testing in small increments. And that can be really, really dangerous for the health of your product, but also for your total release process. So please automate. The same applies to tests. I think it's really, really important to automate every test you can. It doesn't mean that manual testing is not needed. It doesn't mean that exploratory testing is not needed. It just means that there's a certain set of tests where you don't have to worry that you're going to miss them for a release, and they will just be running. And I think that's a really important thing, that also you make sure that those tests will be running and that you fail hard in your build or your release process if a certain set of tests that you already automated are not running. Yeah, I just said this, and I think it's super true. Like, manual testing will always find bugs. Humans are not perfect. That's also why GitHub is such a great tool when users come to you and just figure out that there are certain bugs and they're going to fix it. Your releases should be automated. I mentioned this at the first point already. I can just reinstate this. Like, I think releases are so crucial to the whole process, including testing, that you can't let them out there. Everyone should be able to do a release. And think about the non-technical aspects that are really hard to automate. This whole illusion of a release that is done the moment stuff can be downloaded is really wrong, right? You have to make sure that you probably ensure that your documentation is also ready, right? That's just a small thing, and it's still rather technical, completely independent from all the marketing stuff that you usually try to do around releases. If you want to highlight certain features, that's something you can always do step by step. But you still have to keep a certain order, and all of those things are much harder to automate. So I think this whole story of automation and testing for that, it's never really finished from my point of view. All right, that was my talk. I'm going to take a look at Slido now and see if there are any questions. So there is a question: what is the difference between rolling upgrade, can release, and blue-green deployment? I think that's a lot of different terms, and they also mean different features. Like blue-green testing usually means that you test things where you test different implementation and you match those up. And the rolling upgrade in this case means that for the Elasticsearch cluster, you always strive to have your whole cluster running on the same version. So if you upgrade from 7.5.1 to 7.5.2, you do this step by step, but in sort of one go. You don't do any A/B testing or something for that. You should just strive for the cluster to be the same. And I think that's a really crucial, important part here, like that it should only be a short amount of time where you do this, but it still means that as a product and as a test scenario, we have to support this point in time. And we don't know what the user is doing at that time, so we have to make sure we still support like running for that potentially for hours if you have a cluster with several hundred nodes and you're running or upgrading it in a rolling upgrade. And that was the important point I wanted to make there with the rolling upgrade. Like your product needs to have the ability to run different versions in a compatible way. That doesn't mean that all the earlier versions need to be compatible, right? It just means that the latest 6.8 version of Elasticsearch is compatible with the latest 7-point-something version of Elasticsearch. There's no need to be fully backwards compatible just between those two versions. But that is what you have to guarantee if you want to make sure that these kind of rolling upgrades are smooth. And the other way would be to kind of have a second cluster running in parallel and reindexing all your data over there. But that is usually involved with a lot of more work to support this infrastructure. And that's something that as a user of a product, you usually try to avoid because it drives your users away from upgrades. Okay, I think we have an alternative or a second Zoom where we can have more Q&A after that. So I would just say we go with that. Let me see if there's any more chat messages. I don't see anything. So if you have questions, I will be available in the Zoom. Apart from that, I will, of course, put the slides online so you can watch them, including all the links. I will tweet about that later. So feel free to follow me or give me a ping if I forget that. And that's that. Thanks a lot for listening and enjoy the rest of the conference, including the closing keynote. Thank you.